programming problems. Okay, next, uh, what is linear programming? It is a technique for choosing the best alternative from a set of feasible alternatives in situations in which the objective function as well as the constraints can be expressed in linear mathematical function. Okay, I hope you guys are having your books and pens. Please note it down. Okay, I'll just dictate it for you. Okay, so linear programming. So what is linear programming? It is a technique. It is a technique for choosing. It is a technique for choosing the best alternative. It is a technique for choosing the best alternative from a set of from a set of feasible alternatives from a set of feasible alternatives in situations in which the objective function the objective function as well as the constraints can be expressed can be expressed in linear mathematical function can be expressed in linear linear mathematical mathematical function. So I'll just explain what is this. So you might know if there is a problem, we can have multiple solutions. Okay, so in which we'll be having some feasible and some non-feasible also. That means feasible in the sense which we can implement and which we may not implement due to various reasons. Okay, so out of these feasible solutions, so which one do I choose? Okay, so I need to choose the one which gives me maximum output in in the way I want. Okay, in the way I want, in the sense if I want to minimize something, so minimization of cost, if that is my goal or that is my objective, so I need to choose an option where I'm getting the lowest cost. Okay, or if it is the maximization, so in terms of sales, so if you see, I want to increase my sales, I want to choose an option where my sales are increasing or my sales are at the maximum. So this is what is linear programming, or here a set of feasible alternatives. I told many are there, so out of which feasible alternatives are some, so in which I want. Okay, so in which the objective function as well as the constraints. So objective function in the sense, what is my objective? It is to maximize or minimize. In this case, only two things can happen, that is maximization or minimization. So here my objective function as well as the constraints. So constraints in the sense some limitations, okay, or what do you call in other terms, some restrictions. Okay, these are constraints means restrictions. So if you want to do something, there might be some restrictions, right? So as of now, if you want to go out of a house, there are restrictions. Only at this particular time you need to go. You can buy only this, and only these kind of shops should be open. So in that we are having some grocery shops, medical shops, hospitals. Okay, so these are some essential things. So we are in some constraints as of now. We are in some of the constraints. So if you want to go out only this particular time, you can go only at this particular place. We need to maintain social distancing. We need to wear masks. We need to use sanitizers most often. So these are some of the limitations or restrictions, what I can call. Okay, earlier or pre-COVID, we did not have anything. We could go out of the house anytime we want. Okay, we can go to any place. You could have gone to park. You could have gone to theaters. Okay, you could have gone to the colleges. But now that is not allowed. You can go only to hospitals. You can go to medical shops. You can go to grocery shops, or you can go to vegetable shops. So these are the only places which you are allowed to go. So these are the restrictions that are imposed. So similarly, when you are having some objective or something, some problem is there will be some limitations. So those are called as constraints here. Okay, so here objective function as well as the constraints can be expressed in linear mathematical function. So this word is very important, linear mathematical function. So what is this linear mathematical function? Linear in the sense in a straight line, so you already know it. Okay, linear, and the constraint should be in the format where I can express them in mathematical function. Okay, like equation of a straight line y is equal to a plus bx. So something like that in a linear function, even the constraints could be able to put it in that particular way. Then only we can use LPP. So here, if you see what are the important words to remember. So here I am having technique. Okay, choosing the best alternative, then feasible alternatives, then objective functions and constraints. So these are some of the important words which you need to use in your describing of linear programming problem. It's a technique. So where we are choosing the best alternative from the set of feasible alternatives in the situations where I am having a objective function and constraints which could be expressed in the linear mathematical problem or linear mathematical function. So this is the definition of linear programming. Okay, so I hope you have no doubts here. If any doubts are there, please let me know. So this is what is linear programming. Next, structure of a linear programming. So everything has some structure or some steps to be followed. Here also we are having three basic elements in formation of a linear programming problem. Okay, so these are three things, that is decision variables, the object function and the constraints. So what is decision variables? There could be two things. Okay, so two variables. We'll take variables here as x1 and x2. So if there are multiple variables, one x1, x2, x3, x4, x5, but here in LPP we are using graphical method. You are having only graphical method. So our purview will be having only two variables, that is x1 and x2. So out of these two you need to choose whether I need to go with x1, x2 or combination, and even it tells you what combination you need to go, like 10% of x1 and 90% of x2, or 30% of x1 and 70% of x2, or vice versa. It could be anything. So it could be a combination, it could be only x1 or it could be only x2. So these are decision variables. And one more important thing is they should be positive. So this is very important one. So at the end we write x1 comma x2 greater than or equal to 0. That means decision variables cannot be 0 or in negative. So you should remember this. Okay. So at the end, when we are solving, you can see x1 comma x2 always greater than or equal to 0. Okay, 0 is fine, so it cannot go to negative. So some variable cannot be negative. So this is the last equation, that is non-negative constraint. We call it as non-negative constraint. So while solving the problem, we will get to that. Okay, so this is non-negative constraint. So x1 comma x2, as I told you, both are decision variables. x1 comma x2 greater than or equal to 0. Next is objective function. So what is my objective? So objective function, it is given as OF. OF. So in the problem also we'll write it as OF, comma, or two dots. Then we'll write what is the objective function. So here having only two things, as I told you. One is maximization or minimization. So objective function we write max z or min z. Here max z or min z. We cannot have both. In essence, we can find out the maximum and minimum. We are finding out for all. Then we need to choose accordingly whether it is maximum or minimum. We have to choose the maximum value out of your all the solutions or minimum. So maximum or minimum. These are the two objective functions. So z we just generally denote it as max z or min z is equal to the objective function. Again, it has to be written in a mathematical format, linear function of a mathematical format. Okay, this is max z or min z is the objective function. Then next are the constraints. So you can have 1, 2, 3 or 5 or any number of constraints, but again these should be able to put in linear mathematical functions. So in the format of linear mathematical functions in x and y. So sorry, not y, x1 and x2. So these constraints, it can be many or multiple numbers. We cannot say it is only one. Like I told you, in a present situation, if you want to go out, there is timing, there is some things that you need to use. Okay, that is in the sense mask. It could be sanitizers. Okay, and even the constraint is you can go to only few places. So these all are different constraints given to you if you want to go out, right? So like this, if there is a problem, so if you want to solve, there will be some constraints. So it could be only one, two, three, okay, or it could be more, four, five, it could be anything. So usually maximum they will ask you for five constraints, and at the end this particular thing, that is non-negative constraint should be there, that is x1 comma x2 greater than or equal to 0. They will not give you that, you need to write, that is we are assuming that there is no variable or decision variable that is in negative format, so it is called as x1 comma x2 greater than or equal to 0. So these are the three constraints. So three basic elements. First is decision variables. We need to know which are the two variables in which we are looking at. Then objective function, whether I have to maximize or minimize. Then it comes the constraints or the restrictions. So how many restrictions are there? We need to check, and all should be able to put it in linear mathematical function format only. Okay, then only we can use this linear programming problem. Okay, next, assumptions of NP model. So as so many things are there, I told like it should be positive only, it should be this only, it should be that only. So similarly, we are having some assumptions. Okay, so again, as and when we say assumptions, so if this doesn't happen, if this assumption is not right, then we'll be having some disadvantages. So there are some disadvantages in this also. There are advantages and disadvantages. Okay, so what are these assumptions? So first is certainty. What is certainty? In all linear programming models, it is assumed that all model parameters such as availability of resources, profit, contribution of a unit, decision variable, and consumption of resources by a unit of decision variable must be known. So everything is certain. So if I want to do something, what are the decision variables? What are the inputs for this? Okay, what is the quantity that I am requiring? So everything should be known. So everything should be certain. So it is certainty. So there cannot be a variable which is not certain. So everything should be certain. I should know each and everything. Then only I can use this linear programming model. Otherwise, what happens? If we don't know also we can use, but minimum number of things should be there, then only we can use this. But if you are failing to provide all the things, then we may deviate in the answer. Okay, so if you want something, if you are not considering something, if that is having a major effect, then your path will lead to a place where we don't want. Okay, so that is where we need to be very certain. So assumption is certainty, where we know all the things like objective function, what it is, so what are the constraints, how much of resources are being used, and in per unit we need. Okay, per unit of whatever x1 and x2 is there, we need to find out. So how much is requirement of that? Okay, so you just listen to me now, try to remember this. Then when we are solving a problem, I'll explain you point by point again. Okay, so we need to know all these things, then only we can use those. So while we are solving a problem, we will find out all these things. Okay, next is additivity. What is additivity? The value of the objective function and the total amount of each resource used must be equal to the sum of respective individual contributions. In the sense, whichever I am using, everything should add up. So for example, if I am using x1 quantity of A and x2 quantity of B should be equal to C. So I should have minimum of C. Otherwise I cannot split into A and B for that particular C. Okay. So if I am having 20 apples with me, I can distribute among two people, 10, 10, 5, 15, whatever it is, 2 and 18. But my constraint here is I need to have those 20 apples with me, and I should know that I am having 20 apples, then only I can share them. So that is what is additivity. If I add both, but that I'm splitting, like for example, one person is having 5 and the other one is having 15. When I add, I should get the total number and I should have it. Okay, that should be present with me. That is additivity. Then only we can go for LPP program. Next is linearity. Okay, what is linearity? So everything we can put it in a straight line. Linear, you know, it is a straight line. So we could be able to convert it into an equation of a straight line. So there, so the amount of each resource used and its contribution of profit and loss in objective function must be proportional to the value of each decision. Okay. So here x1 and x2, again later on we will be putting the numbers there, 1, 2, 3 or whatever value will come. So we will be substituting the values of x1 and x2 with a constant behind that. Like for example 2x1 plus 3x2. So the 2 and 3 what I am using here are the constants. Then we will change the variable, that is x1 and x2 values will be changing. So when I put those values, I am getting the final answer. Okay, so what they are telling you is your final objective function should be a proportional to your x1 and x2. Proportional in the sense, if you multiply it with 1, it will become x1 into x2 or x1 plus x2. If you multiply 2 with 2, it becomes 2x1 plus 2x2. So whatever is that x1 and x2 we multiply, we are getting a final answer. So that is what is linearity. Then comes divisibility. What is divisibility? The solution values of decision variables are allowed to assume continuous values. Okay. For example, it is possible to produce 6.254 thousand gallons of solvent of a chemical in a chemical factory. So that the variables are divisible properly. Okay. So it doesn't mean we are getting a whole number only. Here we can get something in points. So 6.534 gallons in the sense. Uh, so instead of gallons, for easier understanding, we'll take liters. Okay. So 6,000 liters or 6,000.675 liters could be produced in a particular chemical factory, for an example. So we can divide into multiple parts. So that is divisibility. So assumptions what we are making, we are certain that we know all the variables and the parameters that go into this particular problem. Then additivity, if you add everything, we should minimum have that much of quantity with us. Of, for example, raw materials. So if you are trying to produce something, okay, and we are having multiple raw materials A and B, and if you add both, we need to have that much of quantity with me, that is additivity. Then linearity, we should be able to put all these constraints and the objective function in mathematical format. Okay, that is what is linearity. And then last one is divisibility. So I can divide as much I need. Okay, even the answer could be in points. So again, it is not whole, so it is being divided. So that is divisibility. Assumptions of linear programming model. So these are the four major assumptions. Next comes advantages of linear programming. So what are advantages? It helps in making the optimum use of productive resources. Optimum use of productive resources. What do you mean by this? Optimum use of productive resources. As I told you, we are having resources with us. It could be manpower, it could be time, okay, it could be some product, okay, it could be some raw materials, A and B, X, Y, Z, whatever. So how can we make the maximum utilization of it for the function maximization or the minimization? Okay, whatever it is. So we are making the optimum use of the products or the resources that we are having. Okay, next is LP techniques improve the quality of the decisions. As you already know the different feasible solutions, okay, and you have come up with the optimal answer for it. So here we are improving the quality of the decisions that you make by going through this particular LP process, linear programming process, to choose the right solution from the set of feasible solutions. So it is improving, or it is giving you a solution which is having a maximum result or the maximum output that you want. Okay, so we are improving the quality of the decisions. Next is linear programming technique provides possible and practical solutions. Okay, as you have already found out the feasible solutions, so it is possible plus it is practical. Okay, so depending upon if you are taking the proper constraints, then this is very true. So if you go wrong in the assumptions, or if you go wrong in the constraints, then I told you will lead into a place where we have not thought to go, or we'll get a solution which we were not intended, or it could be a wrong answer, basically what I meant. So it provides a possible and practical solution. Okay, then comes highlighting the bottlenecks in the production process is the most significant advantage of this particular technique. So anybody knows what's a bottleneck? Can anybody tell me what is a bottleneck? Yes, students, anybody know what is a bottleneck? In production, usually we use this word bottlenecks most of the time. It could be used anywhere, but most of the time it is used there. So if you know, please tell me. You can try. If you don't know, you just inform me that you don't know. I'll explain what is bottleneck.
So don't know.
Fine, not an issue. So if you see how is a bottleneck, so I'll draw it in a uh, horizontal format. Okay. If you see a bottle, you see this is a bottleneck, right? So this is a bottleneck here. So how it is? So it is bigger in the backside, and when it comes towards the neck, it becomes small. So what do you mean by this? So for example, in a production unit, so there are bottlenecks. Okay, so what is bottleneck? I drew a neck here of a bottle. You can see, you already know what a bottleneck is. But why it is called so? In the sense, so if there are machines here, okay, if there are two machines which are producing like 20 quantities each, okay, 20 quantities each, okay, there are different steps, right, in a process. This is one step, this is one step, this is one more step, here one more step is there. So what happens is, when these particular two machines are giving you out 20 products an hour, okay, 20 20, we are getting 40 here. At this particular place we are having 40 products with us. Okay, so but what is happening in the next machine here? The next machine, there is one more machine here which can only process, okay, 10 units of whatever process it could be. It could be cutting, it could be drilling, it could be whatever. Okay, there's a manufacturing process. So here one process is happening here, where these two machines are providing me with 40 output per hour. So I'm getting 40 products from this place. But when I move here, what is happening? I can only finish 10 numbers here, okay, per hour. So what happens? Till here I can move only 10. So here output is only 10 for me. Even though this is, I'm getting 40 here, I can come out with only 10. So this is a bottleneck. We are getting choked here at this particular place. We are getting choked. Why? Because uh, more of input is coming, but my output is only smaller than my input. So here what will happen now? The decision to a decision maker. So how many machines I should put here and how many machines I should put here. So if I'm having two machines in this place which are providing 20 at a time, and I'm having a machine here which provides me a output of only 10. So I need to have four machines here. One, two, three, and four. Then this, instead of getting a bottleneck, it will be a parallel line here like this. Okay, the flow will be proper. As the input comes, we are having the output. So this is what is called as bottleneck. Okay, so we can find out the bottlenecks here. In many places we will be having bottlenecks. So huge quantity will come, but the processing of it cannot happen in the rate that it is coming in, and the output would be very less. So this is called as a bottleneck basically. So more will be coming, but we cannot process everything, and we are sending a part of that. It could be here in this case it is 1/4. 20 are coming, we are sending only 10. So it could be 20, like 40 input and 20 output. So it is 1/2. Okay. But what is happening is we are getting stuck at this particular place. Okay. Here my inventory goes on increasing. So if the work of one day here, it takes 4 days here. So what should happen? I should stop working of this for some days to clear out whatever is there in between here. Okay, so it is very difficult. So we need to use four machines here. Then it will be parallel. So 40 quantity will come in. It will be distributed 10 each in 10 machines, and each machine will give me output of 10 per hour. So this is how production planning is done. Okay, so to find out this also, so highlighting the bottlenecks, it will even tell you where we are getting choked. Okay, so that is what is bottleneck. Highlighting the bottleneck in the production process. Mostly, as I told you, it is done in production only. Okay, then is the most significant advantage of this technique. So as and when we get to know there is a bottleneck, we can take necessary actions. So in this case, what are the necessary actions? I told you, okay, we can go with four machines instead of only one machine, right? So that is what, or we can reduce the machine at the uh, beginning. So instead of two machines providing me 20, I'll put only one machine, and I'll put two machines where there is a bottleneck. So 20 will be the output of the first machine, and input of second machine would be 10 10, and the output would be 10 again. So if you add both at the end, it will be 20 only. So it will be a parallel structure where what is coming in is going out, and there is no wastage of time or material. Or so if it is a huge machine, okay, what you are or a huge part that you are producing, so you need to have much of space again, because we need to store in between to move it. Okay, if it is moving, okay, there is a chain. So one process, if it finishes, it is taken to the next process. So if there is any delay, it has to be stored somewhere, so you need space. So to have space, if you are having well and good, otherwise you need to buy it. Again, there are costs involved in storing. Okay, so you need to make sure that there is a smooth flow of the products from point A to the finished end, or at the beginning to the finished end. So here we are getting what, we are getting the points where there could be bottlenecks. Okay, that is the major advantage. There we can take necessary actions, as I told you, 40 and 10. So put four machines where there is 10. So the output is 40 again. So this is how we find out the bottleneck and solve the problem. So at least reduce the machines at the beginning instead of to make it one. Then put two machines here, or leave it as it is and put four machines in the next stage, so that the output remains in parallel. Next is LP also helps in the re-evaluation of the basic plan for changing conditions. Okay, so what happens, at times there could be, you might have started the process, but somewhere in between some conditions changed. Okay, some raw material that is there was not able to reach the plant at the specific time, or suddenly you are manufacturing different two products, for example. So you already know the sales of each product, and accordingly you are manufacturing. But suddenly one of the sales of one of the product increases suddenly. So what to do at that particular time? Or one sales of one of the products decreases. So I need to produce less of that number. Okay, so these things can be taken care. So again, go back, change the constraints. Okay, then get the optimum solution and change your process to A or B. Like for example, you should have produced 10 quantity of product A, then 10 or 15 quantity of product B. So suddenly what happens, the what do you call, the sales of product B decreases, whatever reasons. Okay, now presently if you see non-essentials, if you are producing non-essentials in this COVID period, everything is closed. So whatever you have produced is there in your godown or in your place. Okay, there you cannot sell it. Okay, the sales have gone down drastically, because even if the people want to buy it, you cannot sell because you cannot open your stores, right, for non-essential. So something like that. So some things happened and your sales fell. Okay, so what, how to manage now to get the optimum output? Okay, so I can stop it and suddenly go to A. Many of you can tell me. So that might be one of the solutions, feasible solutions. But if I do that, will I be able to get maximum out of it? Okay, maximum output, because there will be raw materials which could be used differently for both, and some of them will be same for that matter. So we never know how to do it. So some quantity of B also could be produced, otherwise the raw material could have a life of its own, like only 10 days it will be there. Like for example, some chemicals, paint or something, so it could be used for only 10 days from the time of it is produced. Okay, you cannot store it for months together, it will go off, you cannot use it later. Okay, so it will expire off. So we cannot do that, but still we can use it to produce some things. So now if we cannot sell it, we can keep it at a smaller quantity, so where I'm not getting any losses also. Plus I may have to hold it for certain time, later on the production might increase. Okay, this is what is the LP also helps in re-evaluation of the basic plan. Your basic plan was something different. Because of the change in the conditions, we can make certain changes and get the output again. Okay, so I told you now about the life of a particular raw material. That could be a constraint. Okay, that comes under constraint. So again, change the particular constraint or add a constraint, then find the output of it. Okay, so these are some of the advantages where we can make maximum use of the production, okay, of all the resources that we are having. Second one is we can improve the quality of the decision. Third one, so the technique provides possible and practical solutions. Fourth one, it will highlight us the bottlenecks where we are stuck. So necessary actions could be taken, and we can, if possible, we can solve the bottlenecks. Many a times it happens, we may not be able to solve it. Okay, so you may not be having a particular machine now with you, or in this time of